Here we are on the test review for Chapter 7, Sections 1, 2, and 3. Let's get right to it. For the first one, we have the square root of negative 81. Can we take a even root of a negative? And the answer is no, so we would put no solution. For the negative out front, of course we can, so because the negative isn't under the radical, we'll just do the square root of 81 and make it 9. The cube root of 125, which should be on your card, is going to give you 5. Now the fifth root, here again we have a negative under the radical. It's an odd root, so we certainly can. So the fifth root of negative 1 is just negative 1. Over here, when we square root and a letter with an exponent, we divide by the root number. Since this is a square root, a second root, we would say 6 divided by 2 would give me x cubed. Anytime we go from a even exponent to an odd, we should put the absolute value around it. Over here, 28 divided by 7 gives me x to the fourth. The fourth root of 81, again, straight from your card, happens to be 3. Here, if I take the cube root of 512, that tells me it's 8, straight from the card, and 18 divided by 3 gives me g to the sixth. On this bottom part down here, we're taking these rational exponents, these fractional exponents. We know that the top number is the power and the bottom number is the root. So if I was to rewrite this, I would say square root, we don't write the 2 in, of 25 to the first power. Of course, the first power doesn't change anything, so we're just taking the square root of 25, which is 5. Notice in this one we have a 6x to the 1/5 power. Notice that the x's to the 1/5 power, this one is not in a parenthesis. Next one to it is in. So we're going to write this without the 6 under the 5th root. Here the 6 would be under the 5th root. Notice the difference between those two. Here we're taking the cube root, bottom number is the root number, of negative 64, and then we're going to square that answer. So if I take the cube root of negative 64, I get negative 4, and that squared, again, negative 4 times negative 4 gives me positive 16. Over here, the negative is not in the parenthesis. Notice the parentheses here, not the parentheses here. So I'm taking the negative, and then I'm doing the cube root of 8 to the 4th power. And the cube root of 8 is 2. 2 to the 4th power is 16, but the negative stayed in front the whole time down. For question number 14, here we have a negative exponent. Negative exponents become positive when you move them from the numerator to the denominator. And then simplifying, I'm going to take the cube root of 8 and then square it. Cube root of 8 is 2. 2 squared is 4. Here we have the negative in the denominator. All we have to do is move it to the numerator for it to be positive. Here, remember our bottom number is the root number, and we're taking an even root of a negative. We're going to say no solution. Here, the product rule, when we multiply things, we add the exponent, so I get x, or h to the 7/7, or just h. Over here, we need to have a common denominator when we add these exponents, so I'm going to change this to 8/20ths. And this I'm going to call 5/20ths. And when we multiply, we add those exponents, so I'm going to have x to the 13/20ths. When we have power to a power, we multiply, so I'm going to write that as x to the 15/2 power, and it's already a positive exponent. If we wanted to write it as a radical, and it doesn't ask to do that, we would say the square root of x to the 15 would be x to the 7th square root x. These two are equivalent answers. I believe this is the one we want. When we divide, we subtract, and I notice that the bottom number is bigger, so I'm going to start on the bottom answer goes in the bottom, so 7/8 minus 3/8 gives me x to the 4/8. Well, x to the 4/8 is the same as 1 over x to the 4/8 is the same as 1 over 1/2. So x to the 1/2 power. Over here, we're doing some more simplifying. Again, the bottom number is the root number, top number is the power number, so I'm taking the square root of 25x to the 6th. We're going to get that answer and then cube it. Square root of 25 is 5. Square root of x to the 6th is x cubed, and the whole thing gets cubed. 5 cubed is 125. Power to a power, I multiply, gives me 9. Again, when you divide, you subtract, so I'm going to say x to the 3/4 minus 2/5 power. Need a common denominator, so I'm going to call this 15/20, and this one I'm going to call 8/20. With the common denominator, I can now subtract and get 7/20 power. Over here, we're going to have to add and then subtract a negative, so I'm going to say m to the 2/5 plus 3/2 power, and when we get that answer, we'll divide. Again, common denominator looks like a 10, so this is going to be 4/10, and this one's going to be 15/10, which gives me 19/10. So I'm going to have m to the 19/10, and then when we divide, we subtract, but I'm subtracting a negative here, so it's going to end up looking like m to the 19/10 minus negative 1/6. Minus negative becomes positive. Common denominator looks like it's going to be 60, so if I multiply here, I'm going to get m to the 114/60 plus 10/60, and so my answer is going to be m to the 124/60, m to the, oops, m to the 124/60. We should try to simplify that. I'm going to try to divide top and bottom by 2, and I get 62/30. Simplify it again, I'm going to get m to the, not equals, m to the 31/15. That's a yucky one. And this last section, or second to last section, we're just simplifying. I'm going to split this into 9 times 6, and I know the square root of 9 comes out as 3, square root 6. Here I'm going to split 8 into 4 and 2. These are all even, so they'll come out. So the square root of 4 is 2. This is a leftover. Square root of a to the 4th is a squared. Square root of b squared is b, and then I'm going to put the leftovers in there. Over here, we can multiply them together. I get square root of 18. Split it differently into 9 and 2, because 9 is a perfect square. Square root of 9 is 3 root 2. Down here, I know that we can put these together into the square root of 12x to the 9th. We add exponents. I'm going to split the 12 into 4 and 3, and x to the 9th into x to the 8th and x. 4 comes out as a 2. This is leftover. X to the 8th comes out as x to the 4th. This is leftover, so I have 3x left over. Here, let's split it into the radical on top and the radical on the bottom. I know since we're taking the square root of this, I'm going to split it into 4 times 6. Square root of 4 leaves me with 6 under the radical. Square root of 25 is 5. If we simplify this, neither one of them simplifies as they sit, so I'm going to write them under the same radical, and 40 divided by 5 is 8. Cube root of 8 is 2. Here we go. Again, same deal. If you can't take the cube root of them as they sit, since they're both cube roots, we're going to write them under the same radical, and I'm going to have a to the 7th, b to the 13th, over a squared, b to the 4th. I'm going to, when you divide, you subtract. So I'm going to have 7 minus 2 is a to the 5th, and 13 minus 4 is b to the 9th. I'm going to split up a to the 5th into a cubed and a squared. 9, I think I said 9, but I wrote 3. Here we go with the a cubed will come out as an a. B to the 9th will come out as b cubed, and this b squared stays under the cube root. Make sure you remember these cube root numbers. It's a very common mistake. Here with the number out front, we're going to split this into 10 or 100 times 5. And when we bring stuff out, we multiply it. So when I bring this 100 out, square root of 100 is 10. I'm going to multiply it by what's out there. So I get 5 times 10 is 50 square roots of 5. Over here, I'm going, since they're together, I can write them separately. Here I'm going to break it up into x to the 4th times x. 4th root of x to the 4th is an x out front. It'd be an absolute, no, it wouldn't be an absolute value. We started with an odd, so we're going to leave it. And then I'm going to have the 4th root of x left over. 4th root of 16 is 2. And here we are on this section with the distance formula. Remember, the distance formula looks like x2 minus x1 squared, this is a parenthesis, plus y2 minus y1 squared. Simplifying, I get negative 2 squared plus negative 4 squared. Negative 2 squared is 4. Negative 4 squared is 16. So I get the square root of 20. In simplified radical form, that would be 2 root 5, because the 4 comes out. And as a decimal, I'll let you figure that out, because I don't have a calculator with me. Here on 34, we're doing the same thing. x2 minus x1 squared plus y2 minus y1. Again, we got a minus and negative there. So in the first one, I get a negative 4 squared. Here, 2 negatives makes a positive. Negative 10 plus 7 gives me a negative 3 squared. So I've got a 16 plus 9, which is the square root of 25, which is 5. And as a decimal, that would be 5. Good luck on your test. Study hard.